Welcome back to Advent of Code 2018. On to day 17 now. So that's 2/3 of the way through. Oh, we had a sneak peek of this one last time. This one, some sort of like Dwarf Fortress water simulation. But I think the stats show that people didn't have much trouble with it, so it should be... Oh no, people did have trouble with it. Okay, we got a difficult one then. Okay. Alright. Let's read. You arrive in the year 18. The year 18. Okay. If it weren't for the coat you got in 1018, you would be very cold. The North Pole base hasn't even been constructed. Rather, it hasn't been constructed yet. The elves are making a little progress, but there's not a lot of liquid water in this climate, so they're getting very dehydrated. Maybe there's more underground? You scan a two-dimensional vertical slice of the ground nearby and discover that it is mostly sand with veins of clay. The scan only provides data with a granularity of square meters, but it should be enough to determine how much water is trapped there. Alright. In the scan, X represents the distance to the right, and Y represents down, as always. There is also a spring of water near the surface at 500 0. The scan identifies which square meters are clay. Okay. So there's one water spring. So that's what it looks like. Clay, empty space, water spring. The spring of water will produce water forever. Water can move through sand, but is blocked by clay. Oh, so this is sand. Okay, that makes sense. Water always moves down, when possible, and spreads to the left and right otherwise, filling space that has clay on both sides and falling out. Otherwise, it's a bit of a strange sentence. Okay, so what do they mean by that? They say so the moment the water hits clay, it spreads both left and right to fully fill the space it's in. But I think that's ambiguous. They probably explain in more detail. Okay, let's see. 2 squares of water can't occupy the same location. If another 5 squares of water are created, they will settle on the first 5, filling the clay reservoir a little more. Yeah, sure. Water pressure does not apply in this scenario. If another 4 squares of water created, they will stay on the right side of the barrier and no water will reach the left side. Fine. At this point, the top reservoir overflows. While water can reach the tiles above the surface of the water, it cannot settle there, and so the next 5 squares of water settle like this. Okay. Alright, so the general rule is when you hit clay, you spread out left and right until you either hit clay or you find more sand that you can go down through. And that's what these vertical lines are. And if you hit clay on both sides without falling down, that means you're in like you're in a container and you're kind of stable. So we represent that with the tilde. Otherwise, all the water in that row is represented with vertical lines, meaning it's unstable and it's flowing down. And then the next lot of water, well, the water will then just carry on, okay, down there. But you can have multiple... You can now have multiple streams going. Like you could pour either side. Alright, fine. Get it. Finally, when there is nowhere left for the water to settle, it can reach a few more tiles before overflowing beyond the bottom of the scan data. Right. How many tiles can be reached by the water? They mean within this grid. Okay, fine. Counting both water at rest and other sand tiles, the water can hypothetically reach... Total for this example is 57. Okay, my concern is... Is it unique? Well, yeah, I mean, it would have to be. But, I mean, if you were to process this left column here first, then down below there might be all sorts of crazy stuff going on. And then you went to the right column and then did what the water would do if it falls down there. Would it matter? Would that be a different result from if you were to do the right and left? Because... I guess not, but... Alright, I have an idea how to do this. I don't know if it actually covers all situations though, because they're being generous with these containers. Okay, we can actually look at the input. Let's have a look. Okay, well, from that we can't get a visual picture of it. The first thing we have to do then is parse this and then we'll know what we're dealing with. I mean, like, you could have, say, a diagonal lines for the bottom of your container, in which case We just follow the same rules. Okay, so are there any really obscure containers that could throw us off here? Don't think so. I mean, if you always follow the rules. We're gonna have to use recursion here though, because let's say you process one water spring. Then the moment it overflows, we might have 2 new water springs essentially that we have to deal with. So we'll have to do one kind of like recursively and then do the other. And it could double again, there could be 4, there could be 8, so but as I was worried about order. But I guess it doesn't matter which order you process them in. Every bucket is either filled or not, eventually. So the final result won't matter. Yeah, that makes sense. It doesn't matter about order. Okay. How big's our grid? Well, okay, how am I going to represent the grid? Use a 2D array? Or hash map? Just use a hash map. Because we get them in this order, so we don't know ahead of time how many, what the largest size is or whatever. Alright, so the first phase is just trying to parse this and get a grid. Actually, if we make it a 2D array, then we can actually print it. That's pretty important. We need to see what it looks like. Yeah, no, we don't want a hash map. Okay, fine. Let's get the IDE open. All right, problem 17. Copy the input. Okay, so I think we just put all these coordinates into a list first, and then build a grid, and then put the oh, let me zoom in a bit. What is this stupid Windows thing? Typing left Alt plus Shift changes your input language. What the heck? No, don't do that. Okay, what language am I doing now? How have I never had that come up before? Looks like we're still in English. Doesn't even have a display for the language. I'm still new to Windows 11. Okay, well, I hope it's not switched to American or something like that. Right, for line in f dot read lines. We've got to parse this, so we've got to say, how can we do this? Okay, comma. Okay, we can. Right. Okay, so let's say tokens equals token 1, token 2 equals line dot strip dot split on the comma space. So that gives us 2 substrings. Okay. So okay, fine. Let's say first chord equals token 1. Just get rid of that those first 2 characters. And then okay, and then we just want a list of all of these. We just unpack them all, so we can say A, B equals int Z for Z in token 2 onwards dot split dot dot. Okay, that's a mouthful. So this section here, split on the dot dot, int each of them. So we should end up with that A and the B will be the ints, and then I'm gonna say for K in range from A and including B. Okay, so the end result is we get a coordinates. So this is a map of clay. Let's just call it clay then. Clay equals that. For K from this number to that number included, we want to say if token 1 0 is X, then clay dot append, so it would be first chord K, else it would be the other way around. K first chord. All right, so that gets us all the clays, clay coordinates. Okay, now We want a grid. So min x max min x equals min of P0 for P in clay. So we want to find the min, max, y's, everything. So we want max x and then we want min y and max y. Okay, so we have a grid. Now what? We need let me just test this one more time. I think given now that I've given some time, it might have the correct key now. Test. No, I thought I gave it the streaming key. All right, never mind. I'll leave it up. Maybe it'll just magically start working after a while. Okay, so we need to create a... So is the y always positive? Or... Yeah, we're always in the positives. So let's try printing print min x max x min y max y. Okay, so we're in this region. All right. I'm tempted to just start from 0 just for the sake of no, we don't need to do that. Okay, so width equals max x minus min x plus 1. So we want to create a grid equals, so it would be, let's say, dot for x in range width for y in range Let's just use max y because it's near enough to 0, so we can say max y. Alright, for row in grid, print. So we're gonna just print it. Let's see what it looks like. Okay, so we've got sand. Oh, of course, it's just sand. Okay, and now for each of these clays that we've stored here, okay, for X, Y, in clay, grid, so it's going to be Y, X plus min X. No, minus X minus min X, so that shifts it. Is going to be hash. That's the clay. All right, let's see what it looks like now. What? X, Y in clay. What have I done wrong here? Grid for Y in range max Y. The Y has gone out of range. What? So we've done for Y in range max Y. So whatever max Y is, it's 1897. We should have 1897 rows. So now if we access grid, oh yeah, of course, it should be Y minus 1. Well, yeah, okay. So this is what it looks like. Fine. Okay, so they're quite regular shaped buckets. They're not I mean, they could do crazier things with these buckets, but what am I trying to do? I'm trying to pour water down from the top of this, and it fills the buckets, and then they overflow, and then the water kind of trickles down to the next buckets and so on. You're trying to work out where the water ends up. It's quite complicated. But we've done the first part, which is to just parse the input. So now we've got a bunch of buckets. So the water starts at... Where does the water start? Water starts from x equals 500, y equals 0. Okay. X equals 500, y equals 0. So... spring equals 500, 0. So basically what we want is... a recursive method, which, given spring's location, fills in the water into the map fully. Define get water for and the input will be, I guess, an X and a Y. So this is saying fill out the water path, given that water is now starting from X, this X and this Y. So, well, this is... I keep thinking about what to do with all these. Alright, one step at a time. So, I want to say... while... Hang on. Okay, so if y is, let's say, greater than or equal to max y, that means we've gone off the end of the map, so the water just falls into the void. So we're done. So water equals, let's say, xy. This is where the water currently is. So we're with our cursor, basically. We're trying to follow the path of the water. So while y is less than max y, go y, hang on, we need wx equals xy, while wy is less than max y, just add 1 to it. No, hang on. Man, this is so confusing. Alright, so I'm at a location. I have water where I currently am, so I don't need to process the current square. We want to decide how many steps we go down. So we keep adding y until we get to either clay or water. In fact, I can change this to -1 here, because if we're on the bottom row, we also don't need to do anything. Okay, so while okay, so I'll change this to -1. Alright, so if we reach the bottom row, we also break out. Okay, so we want to see if the if grid y plus, okay, we've got to start using wy plus 1 wx equals an empty space, then we add 1 to y. So at this point, when we've broken out of this while loop, we've gone as far as we can go. Well, break. Okay, so we've gone as far as we can go. So we're sitting either at the bottom of the grid or there's something below us. So let's handle the cases. If also we should update the grid. So grid WY WX equals, so we're going to change it to a vertical line because it's falling, and then we go down one. So we're now looking at this empty space where the water is about to go into. So if we're on the last row, then we just say, okay, we'll put a water there and then we'll just break out of this. And we're done. elif grid so otherwise we have to look at what's below us. If below us is water, then we're also done, because that water will just kind of merge with that water. It won't increase the level. There's no pressure here or anything like that. Oh no, wait. No, if it's... There's two types of water. Okay, if it's... falling water, then it merges, because that means that water's falling, so we merge the two together. Okay. So we just do this again. Alright. Otherwise, the only other possibility is that we've just landed on either clay or stationary water, which we'll use tilled for. So that means we have to now spread left and right to find what's going to happen. So we're going to need a couple of variables here. We need left x equals our current wx, and we need right x equals wx. Alright, so we need to spread left and right. So while my god, this is... Okay, while true... If... So we want to say if... If grid left x minus y left x minus 1, so the space to the left of us is an empty space. Then we move into it. Left x minus equal 1. So we need a variable here. Flow equals false. So if we find that the water's flowing, then we have to change that to true. Okay, so... So if there's empty... So we're sitting on either flat water or hash. So we want to go left until we either hit a wall on the left, we hit a wall of water on the left, or well, there's empty space below us. Into empty space or flowing water. Okay, so if okay, so we have to close off this if condition. If it's, you mean water? Some people in UK pronounce it like that, but I don't think... Well... Most people I know don't, but... I guess that's because most people I know learned English... are not British and learned English from abroad. Alright, so... Can't get my head around these indices, it's quite confusing. Alright, so if we can move to the left, we move to the left. Okay, fine. Otherwise, we break because there's no more to the left. Alright, now, if the space below us is in, so it's either empty space or vertical line, so flowing. Then we've just proved that this water's going to flow. So flow equals true and break. Okay, so either way, we'll break out of this true loop. And we know we're sitting on... Either we've closed off... So if the space below us... So the one recursive call we want to make here is if there's empty space below us, then we want to call this method again recursively from this new space. Okay, so if grid, so let's say if y is less than max y minus 1 and grid. Okay, so I keep mixing up wy and y. I'm supposed to be using wy. wy lx plus 1. Hang on, no. We just want to say if yeah, okay. If the space below it is an empty space, then we want to call recursively hang on. We don't need to make this check. We know that can't happen because we can't be on the bottom row. Also, we can do this here. Okay, let's just optimize this a bit. All right, so if it's there, flow is true, and if additionally it is specifically a dot, then we call get water w, so it'll be left x w y. So this is a new source. Water is now flowing from where we are. Or start from below us. Okay, okay, I think that's good. Oh, one other thing. If okay, if we hit a wall, if the space below to the left of us is a vertical line, flow equals true. Either way we break. Okay, so that's the complete left side, and we end up with LX being the furthest leftmost point the water will reach. Now we have to do this whole thing for RX. So got RX plus 1, RX plus equal 1. WX, oh, that's wrong. Hang on. That should be LX. That should be LX. Alright, and then down here we got RX, RX. RX, RX, RX. Okay, so after this, both of these, we know LX, RX are now spread out as far left and right as they can, and we know if they're gonna flow down or if they stay stable. If both of them stay stable, then flow will still be false. Okay, so now we go for X, or let's say for, I don't know, J in range LX and ending on RX. We do grid WY J equals, so it would be tilde. No, it would be vertical line if flow is true, else we'll use tilde. So we've made the two recursive calls, and that's it. That's a horrible function. I don't trust it at all. One of the worst methods, if not the worst method I've written this entire Advent of Code 2018 series. Alright, let's test it. Oh, we haven't run it. Okay, so we're gonna do get water. Y can actually be 0. So we actually need um we need to add 1 to this max Y because we're including the 0. I think the rest is safe. We don't need min Y anyway. So we wanna get water, spring X, spring Y. Alright, prepare for errors. There we go. So the X has gone out of range. What? Ah, because... Oh, damn it. We need to do spring X minus min X. So it's going to be spring X minus min X. We have to adjust because our grid doesn't actually do that. Okay. Huh. Alright, it ran. Let's have a look. I'll be really surprised if this works first time. So now we've run it. Where's the water? Alright, take off the old grid because Ah, we've got water. Okay, where does it end up? Here. And it fills this space. Ah! And then it doesn't know what to do now. Ooh. Oh, I haven't handled this bit, have I? Okay, so it's correctly doing one layer, but then it doesn't know what to do. Okay, so if we've hit stable water, I think we need to backtrack. If it's not stable water, it's fine. We can just leave it. If it's stable water, i.e. we specifically use the tilde, Alright, so after this is done, if we're now looking at tilde, so if grid wy wx is tilde, I think we're going to go up, back up one space, wy minus equal 1. I think we should set grid, set it to empty space again, and now rerun get water on this place here. So it's gonna process another row, see what happens on that row. So basically undo this water here. And that might repeat back up the chain. So any of these vertical lines can later on become a tilde, stable water. That makes sense. Okay. Okay then, let's try that. Alright, what's happened now? So the water comes down, it fills container successfully. It gets blocked off on the right. So it flows to the left. Good. Then oh, that's interesting. Oh. That's not quite right, is it? So what are we expecting to happen here? We expect the water to hit that surface there, go left and right, so there should be vertical lines here only. And then it'll pour down. So then we'll end up with these two rows getting filled, and then the water pouring down here will form stable water here, here, and here. Then we go here. Now what happens? basically, this should be stable water. We want that to get changed. What happened here? So the moment this gets filled, we then turn that to an empty space. We do the water again. Ah. No, wait. Okay, so at some point, I think these were all dots. This was a vertical line. These were vertical lines. So we filled that, and then we backtracked up here. We changed that to a dot. We run get water again. Then what happens? So we stop there. Ah. So then it hits this here and it thinks it's flowing. Okay. Oh man, this is tricky. So basically it thinks water's flowing because it sees this vertical line, but actually that was flowing towards us. So that actually gets cancelled out. It should become stable. Oh. Alright. So I think when we see this vertical line, we don't want flow equals true there. What do we want? I think we want to do this. We want to say if it's in either of these two. So we actually include the vertical lines in our left-right finding. So if it's in any of those spaces, we move to the left. So we take that out. All right, so we keep going until there's even if there's flow, we keep going. All right. If there's flow below us, flow is true. If there's empty space below us, flow is true. Same is correct. So if I do that for the right-hand side as well. Take that out. So now the left-right pointers will go all the way to the end, not just... Let's try running that. Bollocks. Oh, recursion depth. Because It's a big graph. Fuck. What depth are we getting? 1,000. Well, that'd be really naughty. And increase the recursion depth to 2,000. Now I know last time I played with the recursion depth limit, I crashed my entire computer. I had to end the stream. Oh, I had to reset my computer. But that's because I increased it to like 1,000,000 or something. If I just increase it to 2,000, just because I know the numbers are never go beyond 2,000. Yeah, I think I can do that. Never do this at home. Still too much. How much recursion are we getting? Oh. Oh no, we're not. It's not recursion error now. It's Rare to see you so stuck. I don't think I'm stuck. I'm making progress. It's just takes a while to code it all. Alright, so what now? This is out of range. We've gone off the edge of the... Oh, of course. So, the max X is the rightmost point where we have a clay. We need to add one column to the right. Because we need to give space for water to roll down the side, so max X plus 1. Okay. Oh, look at this. We have water in this big bucket, and then it flows over there. That looks correct. And then we've got the bucket here. That looks correct. And then we've got up here. So there's no water pressure, so that also looks correct. The water only goes up to there. And then goes up there. Imagine trying to code it with water pressure. And then... Oh, that's weird, but it's not... I mean, okay, that's not what I wanted to happen, but it's still water. So it might still be correct if we just include the vertical lines, which we will anyway. That's supposed to change to tilde, but I don't think... That's an obscure situation I haven't handled. Okay, whatever. But I mean, otherwise this looks really good. Like, very plausible. Now I could be off by 1 or something if I'm including 1 extra row or something. Okay, well, let's just print out the answer then. So the answer, okay. total equals 0 for row in grid, for car in row, if are in hash vertical line, total plus 1, print total. 26227? No, I could be off by 1 or something because I don't know if I got exactly the right size grid here. I kind of adjusted it to make things work. Not correct. Too low. Alright, let's try the example then. $64. My answer was too high. Okay, does my map look correct? So the final result should be... Oh no, I'm counting the characters wrong. Not hash, it's tilde. So yeah, it was completely wrong. 59. No, but the answer should be 57. Oh, I think I'm... I've got one additional row. Okay. So I think I've got too many rows. Should I be doing... take off this one? But wouldn't that... No, that's gonna crash. Okay, it works for the example, but... Max... No, it's fine. Alright. Okay, try that with the full example then. Three, 1, 8, 8, 9. So I was counting the clays instead of the waters. Alright, 3, 1, 8, 8, 9. No! Damn it, because it works on the example. Okay, now what? It's too high. Well, I mean, this is something we can actually verify by eye. Oops, I haven't got the HRM open. It's just there's a lot of recursion, but we can just verify every bucket by eye. Or just have a look and see what's gone wrong. So, okay. That looks correct. Then the water flows down here. Alright, that's a bit weird, but it's... we can count that. But the fact that that's happening... probably means somewhere we have an issue where water is landing on these and they should be stable, and that's causing it to assume it's a flow instead of a stable water. Alright, why is that happening? Let's fix that bug, because that's definitely a bug. I just assumed it wouldn't matter, but yeah, I see that it does matter. Probably does. Right, so what happened here? So what would happen? We would get 3 lines, 4 lines, and there'd just be empty spaces to the left and the right. Now water would flow down the left and the right. These would fill up. Then we'd fill up the left. And then the moment this becomes full of stable... This becomes stable. We then place water here. We would go all the way left, move the left pointer all the way here. The right pointer would go to here only. And we would see that it's flowing. We could end up calling recursion... Oh man, okay, there's a situation where... What is happening exactly? Yeah, I can see this is a bit problematic. So... Because we have a second recursive call ready to act. Okay, so this will all become vertical lines. So when this fills up, this will become vertical lines. This is empty space. And then we start filling up from the right. Okay, so it'll fill up as normal. And then we get to this row. And then we delete that. And then we try and do get water on this space again. So to the left of us is vertical lines. To the right of us is empty spaces, I think. Now, what would happen in that situation? You would hope that these all become tilts, become stable water. So you know... Flow. Are we accidentally setting this to true in a wrong place? We're setting it true here and here. Oh no, it's not. It seems like the left pointer is not in the right place. When we do this call here, when we do get water from this spot here. At that point, there should be stable water below us. So the left pointer should keep going left until it's there. Should I change this to... This can't harm us, so let's add a tilde to these strings here. In case there's some weird situation. Same result. Okay. What does that section look like? Oh, where was I? Here? Okay. Well, that's... Was that the same place? Yeah, it was. That's... kind of better, but still wrong. So what's happening now? It doesn't think it's stable. So flow must be... Flow must be being set to true incorrectly. So if the space below us is space or flow, then that's flow, okay. What I don't get is why is this stable above us? That doesn't make any sense. How, well, surely that should also be flow because it sees flow below it. What's happened here? We're saying if we land water on flow, then we don't do anything. I think that's correct, but How did this situation come up? I think it's because All right, let's say some other things as well. If grid WY/WX is already stable water, stable can never become unstable again, so we should just return. I can't imagine why we would ever need to do that. Ah, these get waters might not be safe. Let's think. Okay, so that's using the empty space below us. That's fine. Yeah, so whenever we're calling get water, there's empty space, so why there shouldn't be any situation where that comes up. Yeah, we always run get water on an empty space, so that's fine. How did this become vertical lines? Which call made this become vertical lines? So when that happened, this happened. This was used. That means flow must have been true. So either we said if dot flow below us Alright, I don't yet know what's causing that problem, but let's see if we can find what is actually causing the error, because that still technically would give us the correct answer. It's just the wrong type of water for the visual display. Let's see, so the water falls down there, that fills up, that looks fine. Water falls down here, that fills up, and it rolls left, that's right. Alright, that's another problem, but it rolls right. Then it goes right. And it goes right. Then it goes left and right. Then we got this situation. That's interesting. But okay, then it goes left. Then goes right. Then we go left. I mean, it looks correct so far. We go left. Go left. Go left and right. Then these merge again. But we go left and right. Left and right. Oh, now we branch. So let's see what happens to the left. Oh, we've still got a long way to go, so it's going to branch quite a bit. We'll just follow the left path then. Yeah, there's definitely a... And then it falls into here. Ooh. Well, okay. It looks... You get these weird rows appearing that I don't know what's causing them, but that gets closed off anyway. Ah! Ah! There is an issue here. I don't know if this issue is actually happening, but the water can't flow to the left. We need another row to the left. But it doesn't look like it's actually causing a problem. Nevertheless, it shouldn't be this way. The water actually goes to the right, but still. Let's try and fix that. So we need need to add 1 to the X. Oh, we've already added that. Add 2 because we need something on the left-hand side, and then we want to say am I not using the right should just subtract 1 here. Okay, that gives us space on the left, I guess. Yeah. The water was never actually reaching that point though, so it didn't matter, but anyway. Okay, so the water goes down here. Water goes down here, water goes down here. I still don't see any actual problems. Apart from the fact that those weird rows are appearing in between. Looks fine. So what the heck is the problem? I do still need to debug this thing here because this just shouldn't happen. I'm seeing so many correct buckets, so... Almost correct buckets. Are we counting... Alright. Well, it's... I probably can't find the problem by hand. Unless it's something that's actually just happening on the last row. I'm just surprised it's working this well. It looks... Ooh, what's this? Okay, this is a weird one. Okay. And then that looks correct, fine. And we're almost at the bottom. And then we stop there. So they don't want us to include a row below there. Alright, well, I should probably start by fixing that bug with the, this thing here. Why is this row appearing? So what is the last thing that will happen on this row? No matter what, if we... So when we place these tildes... After placing the tildes, okay, we then so y minus equal 1. Okay, so we place this tilde here. we fill this whole row with tildes. Then we decrease y, so we go to this place here. We say that is now a dot. We set that to a dot. And then we do get water on that space there. So at that point, there should be a bunch of vertical lines to the left and a bunch of empty spaces to the right. But either way, it doesn't matter what's to the left and right. All that matters is what's kind of below us, doesn't it? So as long as we see flow and stuff, should just it's a bit strange adding this tilde here, because why would we need it? That shouldn't ever happen, but ooh, this is interesting. Maybe we're doing this in the wrong order. So we're saying if we see space, so if we're going over to the left, if we see a drop, we set flow equals true. But then we call the recursion here and sort out that water flow. So we should do that first. Okay, do that first. First, do this recursion to add the water trickling down to the left. See what happens when we do that. And now, all right, do that here as well. Because it's remembering the flow from before, but it's modifying the graph after that. That's wrong. That could be causing this issue. So we call recursion, then we set flow if needed. Let's try that. Same number. Let's see what happens. Oh, okay, we fixed that issue. All right. Well, now what? It looks fine. So our x value is that space there. Okay. So we're counting those. It's not a very wide graph, so we can actually check the whole thing. In fact, if I zoom out a bit, it might not look... Okay, it's gonna look quite small now, but let's just do that so that I can actually verify this. Alright, so let's go from the top. We can actually verify the whole graph by eye, I think. Start from the bottom, actually. No, start from the top. Alright, so we're starting here. So that's y equals 500. X equals 500, I mean. I'm not sure that I've got these x values correct, so they need to match up correctly. So, grid, let's have a look at what I've written. So I'm saying the first column in my grid corresponds to x value of min x minus 1. The min value minus 1. So whenever I put stuff in the graph, I always do x minus min x. Is that right? X minus min x. Grid y minus 1. Is it y minus 1 or y? What happens if I do y? Out of range. I think it's... yeah, it's minus 1. So if they gave me a y value of 1, oh wait. So I have a row 0. If they give me a value of 1, I would not want to use row 0. This isn't right. Okay, so we want y here. But then why do I get the index out of range? I thought, okay, fine. This might be the source of the issue. So then that gives me a situation where y is out of range. Okay, okay. So the max value, let's say something like 1,800 or something. Do I just add 1 here then? Was that the issue? I literally had to add 1 to max y and remove 1 from there. Or add 1 there. So last time I had that index error, I just kind of assumed, oh, it should be -1 then. I didn't actually think carefully about that. But at least we also fixed the bug where we had weird flow in between. All right, so 31890. No, it's too high still. Let's check the example now, because I don't know if I've got the right columns and everything. $58. That's wrong. I've got 1 additional row. Oh! Because they are not counting. Oh, they're not counting this as water. That's a tap. So it's literally just total -1. Because I was counting it as water, but they're counting it as a physical object that's producing water below it. So it's a kind of... Alright. So I guess it's just whatever we had -1. Wait, what? Yeah, 31889. Still wrong? This time they... Interesting. So before they said it was too high, and now they're not telling me whether it's too high or low. Well, let's check that they actually looked correct for, Let's go back to the test example. $57. All right, so let's see. What does that look like? So they've got the plus symbol there. We've just got an empty space. But other than that, it looks like we have exactly the same width. And down here we've got this. Okay. Oh, that's cheeky. I think I know what the problem might be. Wait, why just... Ah, so in the example they had y equals 1, which was very close to the top. So it... Oh, okay. So we actually have to ignore all lines so from the top, we have to ignore all the rows that don't have any hashes in them, basically. I see. So that's why the easy case passed and the one failed, because in the bigger case they gave big gaps. So here, when you say for rowing grid, for character in row. So here we can just do a little hack here. We can say if no, hang on. For rowing grid, so it's got to be min min what? Okay, we actually need to know the min y. I deleted that because I thought we wouldn't need it. Min y. So we're going to go grid from min y. So for example, if minimum y is 1, then we would go from 1 onwards. 56, and don't subtract 1. 57. Okay, but that's the test example. Now let's try it for big case. Yeah, that was just me making an assumption from the example, but 31883. Eight seconds. I gotta wait 8 seconds. Oh, okay. So can I do it now? Yes! Part 2. After a very long time, the water spring will run dry. How much water will be retained? In the example above, water that won't eventually drain out is shown as tilled. A total of 29 tiles. How many water tiles are left after the water spring stops producing water and all remaining water not at rest is drained? That's easy, isn't it? We just count how many tills we have. So that's why it was important to get our tills working correctly. So that fixing that bug earlier was worth doing. Alright, so stable equals 0, let's say. $2.927. Alright. I'll have to finish after this, if this is correct. Yes! Okay, it was an easy part 2. Actually, I knew it was going to be easy because everyone who solved part 1, only 39 people didn't solve part 2. So basically, everyone who solved part 1 was quickly able to solve part 2. Yeah. Ooh, 33 minutes was the fastest time, so this took people a while. Normally they do it in like, the fastest guys do it in like 10 minutes or something. This was actually quite tricky. I mean, it's not... My approach was... I'm not even sure that my approach was particularly good. I think there's probably smarter approaches to this. Alright. I think I will finish there. My brain's already fried. I can take a sneak peek at 18. It's another 2D map or something. Looks like they're cutting down trees. More Dwarf Fortress, yay. What the? Okay, alright, that's a sneak peek. This is my leaderboard. Okay, and I'll have to fix the chat widget for next time as well. Alright, I mean, that was a good problem overall. Just, as always, I made lots of bugs. I'm pretty sure there must be a much cleaner solution for simulating the water, which doesn't have... I'm pretty sure there was a race hazard issue in the way I was writing it, which was eventually resolved, but you clearly need recursion because water does kind of branch out, so you need to recurse on all the branches. But yeah. Alright. Thanks for watching. See you next time.